Okay, so today we're going to be looking at linear search and binary search. So let's start off with an example of linear search. So linear meaning straight means we're going to kind of look through a sequence in a straight sequence. And we're going to be checking each data element in the list until the target is found or we have reached the end of the list. So if we look at the example below and imagine the list 10, 50, 30, 70, 80, etc. is a list of numbers, and we're trying to find the number, and we can use the example in the image, which is 20. We're simply going to start from the beginning of the list and keep looking at each element we come across as we progress through the list until the data element that we're looking for is found or we reach the end of the list, which in this case would be position 8 or 40. Alright, so some information we should know. So linear search doesn't need any kind of order, so we can be given a list in any order. We don't need to sort it. We don't need to use any sorting algorithms to do that. It's also efficient for small data sets and inefficient for large data sets. So we can imagine that if we were looking for 40, in this case we could say 40, which would be the last element of the list, we will have to go through every element until we reach that. So if our list was 1,000,000 numbers long and we wanted the number which was just happened to be at the very end of that list, then it would take 1,000,000 steps to get there. So as we can imagine, not very efficient for a large list or a large data set. Alright, so let's look at the actual code that we need to do this. So here we can see there is found equals false and I equals 0, which is initializing those first variables. Then we're using a while loop, so a form of iteration, and while not found and not end of the list or not end of data set. So that would be, as we mentioned earlier, while we haven't found the data and we haven't reached the end of the list, then we can compare the item we're looking for versus what item we're currently looking at. So that was, if we're looking for that number 20, is the number we're looking at right now, is that 20, or is it just another number in the list? So we're going to be sequentially going through each element in the list until we reach the end of the list or the target is found. There's many ways to do this, many ways to code this. We can even use different kinds of loops. So we can imagine if we had a for loop, if you're familiar with coding, in this case it's more similar to Python. We can use a for loop, maybe a for in range, to sequentially go through each element in the list until we have reached it. Alright, now let's move on to binary search. This one's a little bit more complicated, so we're going to go through a little bit of information and the steps needed to before we show an example. Alright, so data needs to be ordered, so we're actually going to need a sorting algorithm before we do this. Before we do the binary search. It's also more efficient than linear search on average because you'll see in a minute, but we're going to go through a different kind of step process. It's also using a method of divide and conquer. So if you haven't come across this, it's a form of decomposition, you could say. So steps are needed to do this. So imagine we had a ordered list. We're going to find the midpoint of the list, and that will be done by just getting the number in the middle. And we can do this by doing the lower bound, which would be the very bottom of the list, versus the upper bound, which would be at the very top of the list, and then adding this up and dividing by 2 to find that middle number. Then we're going to check if that midpoint we just found is equal to the target data. So target data would be the number we're looking for, and if we have found it, if it is a very middle number, then great. But if not, then we are going to have to compare that midpoint. And we can see if midpoint is larger than target, then we're going to disregard that right side. So if we had a number list, all 1 to 20, which is 10, and our target was 5, if the midpoint, which is 10, is bigger than our target, which would be the case, then we're going to disregard that whole right side of the list, because all numbers more than 10 are obviously going to be irrelevant. And we know that our target data is not going to be in there. And vice versa, if the other way around, then we're going to disregard that whole left side, and we can only look at the right side. So just by step 1, or maybe I guess you could say step 2, we've already disregarded half of that data set. And we'll repeat this until we have no more sides to the list, so we're only looking at one, or we have actually found our data. All right, so let's look at something a little bit more simpler, and we're looking at diagrams. So as I was saying, we find the midpoint by doing the upper bound plus the lower bound divided by 2, div 2. So when we're using that operation, it's a mathematical operation, we will be disregarding the remainder, ignoring the remainder in that case. So if we're looking for 75 in this example, first we're going to look at the midpoint, which is position 4, which will be number 23. We can see, is 23 bigger than 75? It's not. So then we disregard that whole left side of the list. Now we're only looking at numbers between position 5 and position 9. Right? So 34 and 78. Then we're going to again look at the middle number, or the midpoint, which is in this case position 7 or 65. Then we do the same comparison, and then we are looking on the right side of the list, which is iteration 3 now, and is the midpoint equal to our target? It is, so we have found our number. Alright, so let's look at the pseudocode for this. If you are in GCSE, you will not need to know the pseudocode for this, but in A level you might be, and it may just help your understanding of it. So the steps again: find the midpoint of the list, check if the midpoint is equal to the target data, and then we'll be disregarding the left or the right sublist. Sublist just meaning a section of the list, so we'll be disregarding that left side or disregarding that right side. And we're going to repeat this process until our data is found or there is no more numbers to check. So if we look at the pseudocode, we're using a while loop, and then we're finding the midpoint, which is the lower bound, or the min plus the max upper bound, divided by 2, and then doing those comparisons, disregarding one side of the list by changing our upper bound and lower bound to different sections of the list, and then again doing our midpoint with that. So in summary, linear search, we do not need any order. We go through the list in the order the list is given, which is sequential. We don't need to do any kind of sorting before that, which is different to binary search. Binary search needs to be ordered. So we need that order to be able to disregard those sections of the list. It's very important. And we just follow the steps of divide and conquer, which, as I said, was decomposition. And that'll be it. We will either get there, finding our target, or we'll reach the end. All right, I hope it helped. See you next time.